Vector components then. Let's talk about unit vectors. And all a unit vector is a vector that has a length of 1. That's all it is. Now, every vector, other than the zero vector, has a corresponding unit vector. So something that's in the same direction, but of length 1. The symbol we use to represent that unit vector is the vector itself, but we put a caret on the top. And that tells us, hey, we're talking about the unit vector in the same direction as the vector A. So consequently, its magnitude is 1. So if I wanted to find that length, I could then basically get the vector A and divide it by its magnitude. The answer, of course, has to be 1. But then there's these two very special unit vectors. You see, all vectors can be written in terms of its components, and it's really convenient to make those components perpendicular to each other. So for convenience, horizontal and vertical seems to be a good way to go, because that's going to be perpendicular to each other. So I is the one we usually use for going in the horizontal direction. We go something like that, and J is the one we tend to use for the vertical direction. So now, the component form then of our position vector. Now there's our position vector, OP. Right? It's a position vector because I've anchored it to the origin. The coordinates of P is XY. Okay, I'm going to call that the vector U. I don't know why I didn't call it the vector P when you think about it, but anyway, I called it U. So our vector U, there I've written it as a tilde. I could write it as a position vector, OP is going in that direction. You can write it as an ordered pair. I'd steer away from that notation because it's too easy to confuse that. Am I talking about the coordinates of a point, or am I talking about a vector itself? They are sort of the same thing, but it can get confusing. I personally prefer writing it as a column vector, which we do like that. So a couple of parentheses, and then we have the X on top and the Y on the bottom. And of course the other way we could write it is simply write it as those two vectors added together. The unit vector is I, but I'll multiply it by its length. Well, its length's got to be whatever the X value is. So it's X times the I, and then Y times the J. Again, it highlights why we put the tilde under the vector. So I is the vector, X is what we're multiplying it by. So the magnitude of our vector then, well, distance formula, square root of X squared plus Y squared. The direction would be whatever that angle is, which we know would be the inverse tan of Y over X. It's very similar to what we do in coordinate geometry. The equal vectors have the same magnitude and direction, and that's what I was saying about why it's so useful to play with vectors, because hey, there's a vector, but I can translate that to somewhere else. It's still the same vector. I could put it up there, it's still the same vector. To calculate the position vector, then no matter where it is, I just go head minus tail and I'll get the same answer. So let's say B is the point 3 naught, A is the point naught, negative 4. Then I know the position vector of that is 3, 4. That's our vector, 3, 4. CD, there's the coordinates of CD. I subtract them and again I get 3, 4. So therefore, I actually know P must be the point, 3, 4. Because then when I anchor it to the origin, I get the same thing, 3, 4. Write that in component form this way, where it becomes 3i plus 4j. The unit vector then, in that direction, would be 1/5 of P. So I get the vector divided by its magnitude. The magnitude of this one is, well, the square root of 3 squared plus 4 squared, which is 5. Now I deliberately put the 4/5 in parentheses here to highlight something. Okay. Notice the vinculum is there. Vinculum, by the way, name for the bar of a fraction. It's there. That's not a vector. That's a number that I happen to have put parentheses around. The reality is I wouldn't really put parentheses around that. I'd write it as 4/5 j, but I just put that there to highlight the difference between the two. So there's our second bit of theory for today.